Hello friends, welcome back to my YouTube channel. So in last video we have seen a problem of sway frame problem. Today we will see one more problem of sway frame problem. This is the given problem. Analyze the portal frame loaded as shown in the figure by slope deflection method and draw the BMD. So as usual, our first step is to find out the fixed end moment of span AB, BA, BC, CD. So now we will see step by step. So step 1 is to find out the fixed end moment. So here see the span AB is carrying the no load. For the span which is not carrying the load, so fixed end moment for that span will be 0. So our MF AB as well as MF BA. So both will equal to 0 because it has no load. So our fixed end moment for span AB as well as BA is equal to 0. So now for span BC, it is carrying the point load of 10 kilonewton which is not present at the center. For the span which is not present at the center, so we have the formula MF AB is equal to minus WAB square divided by L square, and MF BA is equal to WA square divided A square B divided by L square. So this is the fixed end moment formula for the span, the point load which is not present at the center. So MFBC is equal to minus WAB square divided by L square. So minus W is 10 kilonewton they gave. So 10 into, so this is A. From here to here is A and from here to here is B. So A is 1 meter. So 10 into 1 into B is 3 meter. So 3 square divided by, so L is 4 meter. So L is 4 meter. So 4 square. So simplify it, it will come out as minus 5.625 kilonewton per meter. This is for MFBC. Similarly for MFCB, we have the formula for CB minus WA square. So minus WA square B divided by L square. So minus W is 10, load is 10. So 10 into A is 1 meter. A is 1. So 1 square plus B is 3. So 3 divided by L is 4 meter. So 4 square. Simplifying, it will come out as 1.875 kilonewton per meter. So now for span DC we need to calculate. Here also the span CD is not having the load. For the span which is not having the load, the fixed end moment for that span will be 0. So MF DC as well as MF CD is equal to 0 because the span is not carrying the any load. So fixed end moment for the span becomes 0. So this is, here our first step is completed. Our second step is to find out the slope deflection equation for each span. So now we will see one by one. So now first we will see the first span AB as well as CD. So here AB and CD are the vertical members. So I want to tell you something for vertical members. So I will first read on the same frame diagram here. This is the injured, this support is also injured. This is the point A, this is point B, point C and point D. So here point AB and DC are the vertical members. So vertical members, it deflect like this. The deflection will be there at vertical member. So deflection is not there for horizontal member BC. Deflection is not there for BC. So our AB as well as DC are the vertical members. So deflection it takes place, which means while calculating we need to add the 3 rho divided by L. For BC we should not add the 3 rho divided by L. At horizontal deflection is not takes place for horizontal member, we should not add the 3 rho divided by L. For vertical member AB as well as DC we should add the 3 rho divided by L. The deflection is takes place. So now we will see by calculating. or MAB. Now we'll see one by one. So we need to use this formula. MAB is equal to MFAB plus 2EI divided by L, 2 into first letter theta A plus second letter theta B minus 3 dot divided by L. It is vertical member, deflection takes place. We need to add the 3 dot divided by L. Now substitute all the value. MFAB value we got was 0 because there is no loading takes place. So MFAB for fixed end is 0. 2EI value they gave for span AB is 2I. Put this value there. 2I divided by length of span AB is 4 meter. So put that value. 4 into 2 into theta A is the fixed end. So at point A fixed end is there. So at fixed end slope is 0. 2 into 0 becomes the 0 plus theta B, it has some value. So it has some value. I am keeping as it is. Theta B minus 3 into delta divided by length of the span AB is 4 meter. So put that value 4. So simplify it. MAB is equal to EI theta B minus 0.75 EI delta. So call it as equation number 1. Similarly, we'll see for span BA. So MBA, now we'll see. So MBA is equal to, we have to apply this formula. MBA is equal to MFBA plus 2EI divided by L. 2 into theta B is the first letter and second letter is a theta A minus 3 rho divided by L. So deflection is there, we need to take the 3 rho divided by L. So substitute all the value. MFBA value we got was 0. So put this value there. 0 plus 2EI value for span BA is 2I. 2I divided by length is 4 meter. 4. 2 into theta B, it has some value. Keep it as it is. Theta A is the fixed and it becomes 0. I am not writing it. So minus 3 divided by length is 4. So simplify it. It will come out as 2 EI theta B minus 0.75 EI delta. Call it as equation number 2. So now similarly we'll do for span MBC. We'll see. So MBC is the horizontal member. There is no deflection takes place at horizontal member. We should not add the 3 delta divided by L. We should not add it because horizontal member deflection is not takes place. So MBC, MBA, in case of AB we need to put the BC. MBC is equal to MF BC plus 2EI divided by L. 2 into first letter is theta B plus theta C minus 3 divided by L. We should not add because it's the horizontal member, so I am cancelling it. We should not take this. So now simplify all the values. Now substitute all the value. MABC value we got was minus 5.625. So put this value. Minus 5.625 plus 2 into EI value for span BC is 2I. So put this value there. 2I divided by length of the span BC is 4 meter. So put this value 4. 2 into theta B, it has some value, keep it as it is. Theta C also it has some value, keep it as it is. Simplify it. So minus 5.625 plus, so simplify it to 2 into 2 4 will get cancelled. Remaining is 2 EI theta B plus EI theta C. So this is a simplified version. I will get EI theta C. So I am directly writing. Call it as equation number 3. Similarly, we will see for MCB. So in case of BA, we need to put the CB. MCB is equal to MF CB plus 2EI divided by L, 2 into theta C plus theta B 3 minus 3 divided by L, we should not add it because it is the horizontal member. So now substitute all the value. MFCB value we got was how much? 1.87. So we got, put this value there. MFCB is equal to 1.875 plus 2E. I value for span CB is 2I. 2 into I divided by length is 4 meter. 2 into theta C plus theta B. So now simplify it. It will come out as 1.875 plus EI theta B. So EI theta C plus EI theta B. So call it as equation number 4. Equation number 4. Similarly, now we will see for MCD. MCD. So it is the vertical member, deflection is there. We should add the 3 divided by L. In case of vertical member, 3 divided by L we need to add. So here in case of AB, you need to put the CD. So MCD is equal to MFCD plus 2EI divided by L, 2 into theta C plus theta D minus 3 dou divided by L. It is vertical member, we need to add it. So substitute all the value. MFCD value we got was how much? 0, because there is no load. MFCD value is 0 plus 2EI value is 1I. For CD I value is 1. Length is 4 meter. Into 2 theta C plus theta B is fixed and slope is 0. So theta B becomes 0. Minus 3 dou divided by length is 4 meter. Now simplify it. It will come out as. So here 4 is there. 2 into 2 4 is there. Both will get cancel. Both will cancel to each other. Remaining is EI theta C. Minus, simplify it. It will come out as minus 0.375 EI delta. Call it as equation number 5. So now MDC is equal to, we have the formula. In case of BA, we need to substitute DC. So MFDC plus 2EI divided by L. 2 into first letter is theta D plus theta C, 3 divided by L, because it is the vertical member, we need to add it. So MFDC value we got was 0. Put this value in our formula. 0 plus 2 EI value is I divided by length is 4 meter. 2 into theta D is the fixed range, slope becomes 0. Theta C keep it as it is, it has some value, minus 3 dou divided by length is 4. So simplify it. It will come out as 0.5 EI theta C minus 0.375 EI delta. Call it as equation number 6. So step 2 completed here. Our third step is to applying the equilibrium condition. So this is the third step, we will see. So we have got the two joints, joint P and joint C. At joint P we have the condition MBA plus MBC is equal to 0. For joint C we have the condition MCB plus MCD is equal to 0. So now we will see one by one. So for joint B we will see at joint B we have the equilibrium condition formula MBA plus MBC is equal to 0. So MBA plus MBC is equal to 0. Call it as condition number 1. Similarly for joint C, at joint C we have the equilibrium condition MCB plus MCD is equal to 0. MCB plus MCD is equal to 0. Call it as condition number 2. First we will solve these two. Later I will tell one more condition is there. After solving I will tell. So at joint P we have the formula MBA plus MBC is equal to 0. Now substitute value. MBA value got is 2 EI theta B minus 0.75 EI delta, and MBC we got was minus 5.625 plus 2 EI theta B plus EI theta C. Substitute MBA and MBC value in our equation. So MBA value is 2ei theta b minus 0.75 ei delta minus MBC value is minus 5.625 plus 2 ei theta b plus ei theta c is equal to 0. So now solve this. So here 2 ei theta b, 2 ei theta b, here also 2 ei theta b, add these two, it becomes 4 ei theta b, 4 ei theta b plus c, there is only one ei theta c is there, write it as it is, ei theta c minus 0.75 ei delta. So here minus 5.625 is there, if I take it right side it becomes 5.625 positive. So call it as equation number 1. Similarly, now we will see for joint C. For joint C, we have the formula MCB plus MCD is equal to 0. Now substitute value. MCB value we got was 1.875 plus 2 ei theta c plus ei theta b, and MCD value we got was ei theta c minus 0.375 ei delta. So put these two value. So 1.875 plus ei, 2 ei c plus ei theta b plus ei theta c minus 0.375 ei delta. Ei delta is equal to 0. So now here 3 is not there, so cancel it. So here also we need to, 3 is not there, cancel it. So now simplify it. Ei theta b is there, only one is there, so ei theta b, I am writing it as it is, and 2 ei theta c and 1 ei theta c, it becomes 3 ei theta c minus 0.375 ei delta, 0.375 ei delta is equal to positive 1.875 is there. If I take this to right side it becomes negative minus 1.875. So call it as equation number 2. Equation number 2. So now what we have to do is, we have to calculate the horizontal equilibrium. For that we need to redraw these vertical members there. I am redrawing these vertical members here. So this is the, here support is point A, this is point B, this is point C, this is point D. The first thing what we have to do is, so I have redrawn same this frame to here, vertical members I have redrawn here. So first thing we have to write down the moments. At point B the moment will be MBA is takes place at point B, MBA. At point A the moment will be MAB will takes place. Similarly at point C MCD will takes place. At point D MDC will takes place. These are the movements, all are clockwise directions. So here the length is 4 meter, here also 4 meter, from the distance of from here to here is 4 meter, and here also from here to here is 4 meter. So now the second thing what we have to do is, here one horizontal force will come HA, here also horizontal force is takes place, call it as S. At point A we call it as the HA, at point D we call it as the HD. So these are also clockwise. You all know in this direction the force we need to take as positive, and in this direction we need to take the force as negative. So I have taken all the moments in positive direction, clockwise direction, so that I have taken the forces also in positive direction. So now we'll calculate. So now we'll calculate the separately for each members. First we'll hide this and calculate for this one. Second we'll hide this, calculate for this one. So now we'll go for AB member. So we need to apply the moment at point B. So summation of moment about B is equal to 0. Clockwise we need to take the positive. So MBA is clockwise. So clockwise we need to take the positive. MBA is clockwise plus MAB is also clockwise. It's moving MAB. So one horizontal load is there. If you rotate like this, so it will move anti-clockwise. So it will move like this. If you rotate, it will move anti-clockwise like this at a distance of 4 meter. So we need to take minus HA into 4. Distance is 4. So now simplify it. Our HA will come out as MAB plus MBA divided by 4. So similarly we need. So now write this one, calculate for CD member. So now we will see, this is a point C. We will solve for DC, applying the moment at point C. Summation of MC is equal to 0. Clockwise we need to take the positive. Here MCD is moving clockwise. So MCD plus MDC is also moving clockwise. MDC minus here HD is horizontal force is there, it is moving anti-clockwise. If you rotate, it will move anti-clockwise. So minus HD into at a distance of 4 is equal to 0. So now solve it. Our HD will come out as HD is equal to MCD plus MDC divided by 4. So now we got the HA and HD. So now we are calculating the horizontal equilibrium. It means we need to do the summation of all the horizontal forces equal to 0. So we need to add all the horizontal forces. We only need to add only horizontal forces. So whatever. So now we'll solve. Here HA is horizontal, HA plus HD is also horizontal is equal to 0. We have only two forces, HA and HD. So now substitute the HA and HD in this equation. HA is MAB plus MBA divided by 4 plus HD is MCD plus MDC divided by 4. So is equal to 0. Simplify it. So I will write here MAB plus MBA plus MCB plus MCD is equal to 0. Now substitute all the value MAB, MBA, MCB and MCD value. So now substitute. So MAB value we got was EI theta B minus 0.75 EI delta plus 2 EI theta B minus 0.75 EI delta plus EI theta C minus 0.375 EI delta plus 0.5 EI theta C. This is theta C minus 0.375 EI delta is equal to 0. Now solve it. EI theta B plus 2EI theta B, it becomes 3EI theta B plus here EI theta C, here also 0.5 EI theta C. So add it, it becomes 1.5 EI theta C minus here minus 0.75 EI delta, here also and here also. Now add these all, it will come out as 2.25 EI delta is equal to 0. So call it as equation number 3. So now what we have to do is we have to solve these three equations. Solve equation number 1, 2 and 3 to get the value of EI theta B and EI theta C as well as EI delta. By solving these three equations, we will get it. Press mode, equation number 5, press and press 2. Our equation is in the form of 2. So now substitute all the values. So our equation number 1 is this one, 4. So 4 is equal to, and 1 is equal to minus 0.75 is there. So minus 0.75 is equal to 5.625. 5.625 is equal to, so our equation number 2 is this one. So EI theta B, 1 EI theta B 1 is equal to 3 EI theta C, means 3 is equal to minus 0.375 minus 0.375 is equal to minus 1.875 minus 1.875. So now put equation number 3, 3 EI theta B. So 3 is equal to 1.5 EI theta C. 1.5 is equal to minus 2.25 EI delta. So minus 2.25 is equal to 0. Is equal to 0. So now solve it. So our x value is nothing but EI theta B. It came 2.05. So EI theta B 2.05. So now solve it for second time. Y value is nothing but our EI theta C minus 1.05. EI theta C value is minus 1.05. 54. So now solve for the one more time. Z value is nothing but EI delta value 2.03. 2.03. So now we got the EI theta B, EI theta C and EI delta value. Now find the final moments. So we have to put these three values. So step number 4 is to find out the final moments. So I will write all the equations first. MAB is equal to, so I have written all the equations here. Now substitute. EI theta B value we got was 2.05. 2.05 minus, sorry it is minus 0.75. EI delta value we got was 2.03. So simplify it, it will come out as 0.5275 kilonewton meter. Now similarly for MBA is equal to, so substitute all the value here. So simplify it. So it will come out as, by simplifying, MBA is equal to 2.57 kilonewton meter. Now for MBC is equal to minus 5.625 plus 2 EI theta B value is 2.05 plus EI theta C value is minus 1.054. So simplify it. This is minus. So simplify it, it will come out as MBC is equal to minus 2.57 kilonewton meter. Similarly for MCP is equal to 1.875 plus EI theta B is 2.05 plus 2 into EI theta C is minus 1.054. So simplify it. So it will come out as 1.8 kilonewton meter. So now for MCD, EI theta C is minus 1.054 minus 0.375. EI delta value is 2.03. Simplified, it will come out as minus 1.8 kilonewton meter. So now for MCD is equal to 0.5. EI theta C value is minus 1.054 minus 0.375 Here delta value is 2.03. Simplify it, it will come out as minus 1.2 kilonewton meter. So this is how we need to calculate the final moments. Next we will see the bending moment diagram. By using this value we will draw the bending moment diagram. So this is our pre-body diagram of the point load which is not present at the center. So this is a 10 kilonewton point load not present as center. To find out this maximum height, we have the formula WAB divided by L. By using this we will calculate the maximum height of this. So WAB divided by L, so load is 10 and A is 1, B is 3. Length is here to here is 4 meters. Substitute this value in that formula to find out the maximum height. 10 into 1 into 3 divided by length is 4. By simplifying it will come out as 7.5. The maximum height of this triangle is 7.5. So now one more thing is, so this is point A, B, here also B, C, here also C, D. So for AB, here negative, here positive, here positive, here negative, here negative, positive, positive, negative, here negative, positive, positive, negative. So by using these signs we will draw the net bending moment diagram by using the final moments value. For MAB, here first point is A. At point A, our value is the value we got was 0.5. So 0.5 is positive. At point A, positive value comes below the neutral axis. It means it comes here. 0.5. It comes here. 0.5. Similarly, MBA, here first point is B. At point B, our value is 2.5. 2.5 means positive. It comes above the neutral axis. Above the neutral axis, it means it comes here. 2.5. If you want, you can write the value 2.5. Similarly, MBC, first point is B here. At point B, the value is minus 2.5. Minus means it comes above the neutral axis. Minus 2.5, it comes here. Above the neutral axis means it comes here. 2.5. For MCB, first point is C. Value is 1.8 we got. Positive means it comes above the neutral axis. It comes here. 1.8, sorry, 1.8. For MCD, first point is C. Value we got was minus 1.8. Minus means at point C it comes below the neutral axis, means it comes here 1.5, minus 1.5. And similarly here MCD, first point is D. Value is minus 1.2. Minus means it comes below the above the neutral axis, means it comes here like this. Join all the lines. So join these points. The net bending moment diagram will be like this. Here positive, here negative, here also negative, here negative, negative, here also negative. So this is our net bending moment diagram of this problem, of this frame, net bending moment diagram. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.